Homework tips for February 21st. Scale drawings. 1 to 1 means that it's a full-scale drawing. You can see 1 with the colon here and then the 1. It's the same thing as a fraction. You have 1 in the numerator, 1 in the denominator. You know that to be 100%. So it would be a full-scale drawing. But sometimes we want to make drawings that are much smaller than full scale so that they all fit on the piece of paper. We certainly wouldn't want to draw a house the full scale or a map to full scale of some city, because then it would be the size of the city. So we have a 1 to 2. That means that it's a 1/2 scale, and you know that this would be the numerator and that would be the denominator, and that's a 50% scale. And 1 to 10 means that it is a 1/10 scale drawing, and we have the numerator and the denominator, and you know that's 10%. So if we had in the drawing a 1 inch, it would equal 10 inches in reality. Or if we had 1 foot, it would equal 10 feet in reality. If we had 1 mile, it would equal 10 miles in reality. Alright, like I said, maps, they're drawn to some scale because it'd make no sense if you drew them to full scale. If house plans were drawn to full scale, like they'd be the size of the house, and that wouldn't make any sense. 1 inch on the drawing would equal 12 inches in reality if we were dealing with a 1 to 12 scale, and this works out nicely since 12 inches is equal to 1 foot. A ratio of 1 to 12 means that 1 inch on the drawing equals 1 foot in reality. Percentages. Well, let's see. If we had 10 people that don't like beans and 20 of the people don't like rice, this would mean that 30% of the people don't like red beans and rice. Lateral surface area, it's just the area that makes up the sides of things. Walls are the lateral surface area of a room, and on a cylinder, the lateral surface area, it's just the sides, it's not the top and the bottom. You can think of it as the label on a can of food. Here I've drawn the lateral surface area. So here we have the lateral surface area, no top, no bottom. But over here I have the total surface area, which includes the lateral surface area, the sides, the top, and we can assume there's a bottom here. The edges of a cube. If we had a cube, I have drawn a cube for you here. Again, I ghosted it a little bit so you can see through it. If this dimension right here is 1, then if we wanted to know the total edges of the cube, these, we could just count them. So we have 1, 2, 3, 4. If we have 4 on the bottom, we have 4 on the top. So that's 8. And then we have 9, 10, 11, 12. So there are 12 edges on a cube. Scientific notation. Nice thing about scientific notation is it's one number followed by a decimal, followed by a couple of numbers, followed by 10 raised to the power of some exponent, in this case 9. So that means we could rewrite this, and this is a short version of writing a really long number. This is really just 3.25 times 1 with 9 zeros following it. And if we multiplied this out, this decimal would move 9 places, and so our decimal was here, and it becomes 1, 2, 3, 4, 5, 6, 7, 8, 9. All I've done is move the decimal 9 places. Don't be tricked or fooled by the fact that it means 9 zeros. It means 9 zeros here, but if I'm multiplying 3.25 times 1 billion, then I would still have the spaces along through here. I'd have 1, 2, 3, 4, 5, 6, 7 zeros, and then these 2 places were where the decimal moved. So it's moving the decimal 9 places. And if I see a positive 9 here, that means I'm dealing with a really large number. If I see a negative 9 here, it doesn't mean that the number's negative. It means that it's a really small number, but still larger than 0. Probability. Let's say I've got a coin and I flip it. I got a 50-50 chance of it coming up heads or tails if it's a normal coin. One flip doesn't have any influence on the other flip. That is, if I'm flipping the coin a bunch of times and it comes up heads, 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 I can't think, well, gee, it's come up heads a bunch of times, so it's probably not going to come up heads this next time. No, it has an even 50-50 chance every time you flip it. If a coin is flipped twice, there are 4 possible outcomes. One of them can be heads heads, one of them can be heads tails, one of them can be tails heads, and the fourth can be tails tails. Dilation. If I have the Cartesian coordinate system, here's my x-axis and y-axis, if I plot a point at 1, 1, the ordered pair 1, 1, and I dilate that by a factor of 2, then I would wind up with the dot being at 2, 2. And this is the ordered pair 2, 2. Mean, median, mode, and range. Mean, it's just the average. Median, it's the very middle number when they're all organized from least to greatest or greatest to least. Mode, that's the number that shows up the most. And range, it's the lowest number to the highest number, or sometimes the number of numbers between the two. Let's take a look at all these. Well, if we're going to look at the mean, it's just the average. You add up all the numbers that you have, and you divide by the total number of numbers. Here I have 3 numbers. They total to 30. And I had 3 of them, so I divide 30 by 3, and I would wind up with an average of 10. Median, it's just the middle number. It's the very middle number when they're all organized from least to greatest or greatest to least. So once I have my numbers and I organize them from least to greatest, I just look to see which one's in the very middle. In this case, it happens to have been 6. If I have 2 numbers that are in the middle, then I would add them together and average them. Mode, it's the number that shows up the most. If you have a whole bunch of numbers, in this case I had 4, 6, 9, 7, 6, 3, 9, 6, I have 3 6s. My mode is 6. It's the number that showed up the most. And range. Here I have numbers, and it's best to go ahead and organize them from least to greatest or greatest to least, mainly least to greatest. And so I have 2, 7, 9, 15, and 22. The range is 2 to 22, or a total number of 20 numbers in the range. Sometimes people use this as the range, and sometimes people use this as the range. That's the end.